of transporting, the goods or the items from one source to a destination, right? So we want to find what is going to be the minimum cost. What should be the minimum cost of these items which are going to be transported. So this method, it's just there to help or to support what simplex method has done. In the simplex method, as you remember, during the simplex method, we want to find the optimal value, the value or the optimal solution, which has to maximize or minimize the cost. Okay, we want to maximize the profit or we want to minimize the cost. So since you have completed the so-called, since you have completed all the things related to the simplex method, and so far I haven't seen the assignment which I gave you. What happened? So you should have done that one, so that I can move on. By hope that you have understood it. So since you have not uh, send anything, so I have considered like you are still trying to figure out or to find a time to send it. But my point or my concern is, please try to solve them as soon as possible. Okay, as soon as possible. So in these regards, okay, in these regards, for this simplex, no, for this not for this transportation problem, I want all of you to pay, before you solve the transportation problem, please try to clear the previous exercises which we have seen. Okay, please try to clear them because they go hand in hand. In all exams, these two methods has to come. Okay, has to come. Please be thoroughly with them. So in this transportation problem, as I told you, we want to find the minimum cost of transporting the items or the goods from a source which is origin to different destination. That's the definition. You can write the definition. And in this transportation problem, it is being solved in a form of table, as you can see. All right. So this is the format. This is a standard transportation problem table, where all this one, as you can see, all the laws stand for, from this law, the law from law S1 to A1 here for this side. This they stand for the source. Okay, this is going to be the source. These are going to be the source for every cells. As you can see, these are the cells. Every cell contain the cost. Okay, every cell contain the cost of transportation. Okay, the cost of transportation. Every cell, from the source 1 to destination 1, we have the cost. From source 1 to destination 2, we have the cost. From the source 1 to destination 3, we have the cost. As you can see, all of these are the what? All these are the source. All these are the costs of transportation from a source to a destination. So the law-wise, as I told you, the law-wise stand for what? For the source. Okay, for the source. And again, for this source, they stand for the supply. Okay, every source is going to be the supply. For the column-wise, like down here, the column 1 stand for the destination. And every destination is need a demand. Can the destination, for example, from a source, let's take an example. A source is going to send like a 200, let's say it's going to be like the cost of 200 from the source, but destination is only 50. What would you do? So you have to reduce and then send according to the destination and the source value. Okay, so the column wise stand for what? Stand for the destination. So every destination needs what? A demand. Every source needs a what? A supply. Clear? That's why we have a demand and supply. Supply there in a row wise, the demand there in a column wise. So we need to find at the end the total or the sum of supply and the sum of demands. Every destination from destination 1 to destination last, they're going to be the total cost. Clear? Now from destination 2 to the last one, to the last source, because as you can see, the lowest they're the source. So we need to find what is going to be your cost or what's going to be your value. All right, so I'll repeat once again. For the low wise, as you can see, is going to be what? The source. For the column wise, is going to be the demand or destination. Every source has what? A supply. The supply value will be on this side, in the far right side. The demand value will be on the round, on the basis of the table. That will be the demand. Clear? So now this is it. As I said, this is square. MN. M stands for source, N stands for destination. M will be taken as what? So yeah, M will be taken as a source, N will be taken as a destination. That's why here we have the same. We are going to have one destination, but different sources. Different sources. The cost for destination 1, cost 1. The cost for source 2, destination 1. Till we go to the cost, okay, of destination of source I. I means I would be a value of the cost for the source, okay? Till we continue, we find M sources, okay? So this is going to be the source and the cost and destination. Is it clear? So for the I is a source, for the J is a destination. All right? So for the demand will be considered as a BN, the total or any number of the demand. All right? Any number of supply will be considered as AM, okay, as AM. Clear? So now this is a mathematical expression, as you can see here, right? So here we assume that M is a source and N are the destination. Now we say let AI be the supply or the capacity at the source I. BJ be the demand. Means every source, it needs a demand or it needs a destination. All right. Now we want to find the cost. Okay. We want to find the cost of transportation from a source to destination. That is known as CIJ. Look at the table here. CIJ. This is a cost of the source to destination. Okay. The cost from source to a destination. Now, here what do we say? We say that something which is called Xij be the number of units shifted from a source I to destination. What is the Bij Xij? The Xij will be the amount of what? Will it be the amount of from the source to a destination, amount of the things are going to be shifted. We may have Xij, which can be the source. We can have Xij, which can be the amount of destination which is demanding, okay, which demands. So we want to minimize what? We want to minimize the cost from the source. Look here, we want to minimize the cost from the source, okay? We want to minimize the cost from the source to a destination. How do? We take the summation. We are going to take the sum, means the cost of this one, the cost of said one. What is the total? What is what? What is the summation? What is the number of, what is the unit to be shifted? Take the cost, the amount to be shifted, or the item to be shifted here. Come here, the cost, multiply into the shifting column. Then we are going to make the summation of them. Okay, we are going to make the summation of the cost into the shifted item plus the cost of the second source to the second destination, and so on. That's the value. We want to find the minimum cost. Okay, we want to find the minimum cost. So there are two types of transportation problem. Number one is balanced transportation problem. Number two is unbalanced transportation problem. In the balanced transportation problem says what? Says that the total supply all the number of things to be shifted should be equal to the number of the demand. That is known as a balance. Look at this one. Look at this table which we have here. Here we have the shift one, the item to be shifted for A1, for A2. Let's say we have like a till A4. We are going to take the A1 plus A2 plus A3 till A4. We get the value. And again, we are going to take the number for demand. For demand 1, B1, B2, B3, B4. If the value of A plus 1, A1 plus A2 plus A3 plus A4 is equal to B1 plus B2 plus B3 plus B4, if they are equal, then we say the transportation problem is balanced. Okay. Second, we say unbalanced when the total supply is different from the total demand. Clear? So these are the two types. So we are going to deal today with the balanced transportation, and you are going to look what are the methods which are used for balanced transportation. We want to look what are the methods to be used for this balanced transportation. All right. So these are the terminologies which we will use. We want to know what does it mean feasible solution, basic feasible solution, not the generate or the generate basic feasible solution. You will go through this one, okay? You will go through this one. So these are the methods which we are going to use to find the so-called initial basic feasible solution. Initial basic feasible solution is a solution which gives us the least cost of transportation from the source to destination compare to all the costs which we have in our given problem. Okay, so we have three methods which we are going to use. Number one, we use something called northwest corner method. Number two, least cost method. Number three, Vogel's approximation method, or this is termed as a VAM. Okay, VAM. So I'm going to explain today northwest corner method and the least cost method. Two, okay, northwest corner method and the least cost method I'm going to explain today. So these are the steps which are going to use for the northwest corner method. Remember, we want to apply this when the transportation problem is balanced. The supply and the demand should be what? Should be equal. Now, step number one, we want to identify the cell at northwest corner of transportation matrix. Remember, it will be in a form of tabular format or in a matrix form. Step number two, allocate as many units as possible to the cell without exceeding supply or demand. Then cross out the row or column that exhausted by this assignment. Means what? You want to look from the normally, not normally, always in this northwest corner, it used to be this one. This would be the first cell to be selected. Once you select this one, you are going to compare the demand and the supply. Now, you put in the corner here the demand or the list between the demand and the supply. Then you subtract from both sides. This is going to give you 0. The value which gives you 0 or the difference which gives you 0, what are you going to do? You are going to cross off, okay? We are going to cross off. That's the first rule. Second rule for the second step, all right? We are going to cross them off. Third step, reduce the amount of corresponding supply or demand, which is more by allocated the amount. So we are going to allocate the amount in that first cell in the corner, and then you are going to do what? To reduce the corresponding one, okay? The one which is equal to 0, we are going to cross them off. Again, identify the north. For the remaining cells, you are going to identify, you are going to repeat which one? You're going to repeat step 1 and step 2, okay? that is going to identify them until you find the last limb requirement are satisfied. Means until you find all the cells are satisfied, and then you find the total. Total will be what? Total will be this one. Watch this one. Okay. Watch this one. Let's go to the table and we see the examples. Okay. And we see the examples. Let's look to this example from the table. Okay. All right, so look this one. I hope the board is shared. You can see the board, right? I believe the board is being shared. Is the board visible to you all? Yes? You can see the board?
Yes, sir.
Yes. Okay, good. Now, we are going to deal with a transportation problem, northwest corner method. Please follow it, okay? In this northwest corner method, as I told you, it is what? It is formulated in a form of a table, okay? In a form of a table. So I'm going to give you some values here, okay? Which we are going to use in this northwest corner. Look at this, okay? So let me give you the value here. Here, we have the following value. We have the following problem. This is the following problem in a form of table here. Okay, so my table is going to be made by 4 demands. First demand, first destination, second destination, okay, and fourth floor, 1, 2, 3. And it's going to be made by 3 sources. This is going to be source 1, this is going to be source 3. Clear? And as you can see, these are the cells. Clear? These are the cells. This is a cell. Every cell is going to contain the amount or the cost of transportation. Okay? This is going to be, let this be 19. Let this be 30. Let this be 50. Let this be 10. Clear? And let this be 60 as a follow. Let this be 20. And this is going to be 70. Okay, and this is going to be 8, and this is going to be 40. Okay, 40. These are the costs. It's going to be 40. This is going to be 30, and this is going to be 70. Okay, 70. These are the costs. Okay, for the source, remember, these are the what? These are the source. This is source 1. This is source 1, source 2, source 3. Okay, remember, every destination is going to be B1. Okay, B1 is what? The total amount, okay, which is required for this destination. This is a destination 1. Okay, you can call like this destination 1, destination 2, destination 3, destination 4. Clear? Now every source is going to have something called supply. Clear? We are going to have the supply. Let me erase the top one. This is not needed. So every source is going to have something called supply. Okay. The supply value which we have for the first one, we have 7. This we have 9. This we have 18. Okay. For every destination, these are the destination. What do we have? We have the demand. Here is going to be the demand. What the demand we have? 5, 8, okay, 7, and what is next? 14. So what do you do? When you have like this one, first you have to check if your problem is balanced. How do we check? You want to find the summation of demand, okay, should be equal to the summation of supply. Clear? The demand should be equal to the supply. All right. So now let's calculate. All right. Let's calculate. Look here. 5 plus 8, do fast, plus 7, do fast, plus 14. What is the value? You can do fast. And the someone, Mona, you can calculate this one. 7 plus 9 plus 18. Mona, you can calculate, and this can be done by Amaltavani. Amaltavani, what is the value for 5 plus 8 plus 7 plus 14? What's the value? What is the value for this one? The value is going to be 13, 20, 34. Clear?
34.
34, right? This one is what? What is the value for this one? Same, 34, right? It's going to be 25, 9, 34. Balance. So this one, as you can see, this value are balanced. Okay, the value are what? The value are balanced. The demand and the supply is what? Is equal. So what do we say? We say that the problem is balance. The problem is balance. Both we have 34. Clear? Just for indication. No need to mention. You mention it because we want to show the indication that the source, the demand and the supply, they are equal. Now, next, for the first step, what do? We want to allocate the corner from what? From northwest. This is it, right? This is it. Now, once you allocate this one, what do? This is the one which is allocated, right? From this far left. Now, what do? You compare the demand and the supply. Which is the least? Is 5. 5 is going to be where? Here in the corner. Okay, 5 is there. Now, when 5 is there, what do? Now, you're going to reduce the selected value. 5 minus 5 is equal to 0. Clear? And 5 minus 7 is equal to what? Is equal to 2. What do you do next? The column or the value which gives 0, what do? You do what? You cross off. I'm going to cross off this one. Okay? I'm going to cross off this one. This is crossed off. Okay? Now, what is remaining? The remaining is these cells. Okay? Remember, this is 19. This is 19. This is 19. Now, in this one, what is remaining? You are going to compare. In the north corner, you select this corner here. You select it, this one. Okay? Between 8, look here. Which is the least one? 8 and 2. Which is the least? It is 2. 2 has to be here. And reduce this one. 2 minus 2 is equal to 0. 6 minus 2 is equal to 6. And then we are going to cross off this one. It's going to be crossed off. Clear? Now, what is remaining? The remaining is this cell. Okay, this region. What do? You look to the corner here. Select the corner here. Okay, now 6 and 9. Which is the least? 6. Clear? Now, you minus this one is going to be 0. Clear? Now, this is going to be closed off. Close off this. It's not needed. Now, 6 minus 9 is equal to 3. Okay? Now, you come to this one, to this region. 40, 60, these are the cells remaining. 4 cells are remaining. What is that? 7 and 3. Which is the least? Is a 3. This one is allocated 3. And this is going to be 0, and it's going to be closed off. And remaining, this one is going to be 3 minus, is going to be 4. Clear? It's going to be 4. It's going to be 4. Now, you look to this one. What are remaining? The remaining is these 2 cells. Okay. The remaining is what? The remaining is it is these 2 cells. What is that? You are going to compare. We have 14, 4, 14, and 18, right? 4, 14, and 18. Which is the least? We select this one. Clear? And this is going to be 4. When we select 4, this is going to be 0, and this is going to be 14. If you want to know that it is correct, what do? Always the remaining value should be the same. Look here. The last one is 14, was 14, right? An untouched one. And the one which we got was 14. Clear? Now, once you do this one, which to close, yeah, this is the last one. So this is going to be 14. It's going to be 14 here. Because the 14, 14 is going to be 0, is going to be 0, balance one. Now, next, we are going to find the summation of cost into allocated value, xij, okay? We're going to find the total of this, of all of this, all right, of all of this. What are they? What are those things which we are going to find? We are going to find the minimum cost, which is called the minimum cost. Okay, minimum cost. What is the minimum cost? What is the value or feasible solution? Initial basic feasible solution will be equal to 5 into 19 plus 2 into 30 plus 6 into 30 plus what? 3 into 40. You can calculate fast, please. Into 40 plus 4 into 70. As I complete this, please you tell me the answer. Plus 14 into 20. What is the value for this one? You can calculate and tell. Okay. So this is known as northwest corner. Okay. Sometimes people they call northwest cell corner method. Sometimes they include CC. Okay. Please tell me what is the answer for this one? 5 into 19 plus 2 into 30 plus 6 into 30 plus 3 into 40 plus 4 into 70 plus 14 into 20. You can tell me. So this is the thing, okay? This is the thing. Please get the answer, please, first. Get me the answer. What is the answer? Ashish or Divas or Chaitra Amson, what is the answer? Take the give me the summation of all this. All right. So once you find the summation of all of this, then I will explain to you the next one, which is called least cost method. Okay. They go hand in hand. So two methods we are going to complete today to see the the introduction of it for the balance problem, and then the third one we shall see maybe for the next class. Okay. So what is the answer, please? You will do it. You calculate this one. What is the answer? Pretty V, how long is going to take? Ashish, how long is going to take? Do fast. Okay, you find the answer. So that will be the final initial basic solution. Okay, you find the last one. All right. So can I erase? Did you take it? Did you take it down, or you are still writing? Can we go? Can we proceed for the next, please? As I begin the second method, please you have to find the answer for this one. Okay, you have to find the answer for this. You tell me the answer for this. What is the value?
1015.
1015, eh? 1015, 015.
Yes,
Is
sir.
it correct? Okay. 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 You will check. Okay. You will check. You can check and you tell if it is correct. All right. So next I'm going to explain to you. Let me erase this one. I hope you have written down this one. All right. So I have erased all of it. So next one, I'm going to explain the second method. When we have a balance problem, the second method is known as least cost method. The second is what? Least cost method. Okay. Both they want to find the minimum cost of transportation from a source to a destination. So look at this one. So the next one is going to be the minimum cost. We are going to have the something which is called least cost method. All right, least cost method. Okay, LCM. Let me give like that. Okay, what is this least cost method for problem? Now, this least cost method, what is it going to do? Okay, in this least method, what you're going to do, you're going to find, okay, you're going to do what? Find the least cost value, find the least, the least cost value, okay, find the least cost value and select it. Find the least cost value between what? Find the least cost value, okay, and select it. Select it. Remember, the cost is what? the cost is identified in the cells. Look at this. Let me write here first so you can understand. So here we have the source. These are the source and destination. The cost one here is 1. Here is 10. Here is 40. Here is 50. Here is 0. Here is 2, 3. Okay, 3, 4, and here's going to be 5. Now, what do? You allocate or you select the least cost value. Which is the least cost value? It's a 0. You selected this one. You get it? So from the northwest method, northwest cost method, what do? We used to find the top from the top left. Okay, from the top left corner we have to select. But in the least cost method, we want to find the least cost value and select it. This is it. If there was no 0, let's say here we have like 11. What will be selected? Which one is the least? Let me give here 100. Which one is going to be selected? Which is the least? Which is the least cost? Which is the least cost there? If you follow, if you understand what I'm saying. Which is the least one? Amaltavani.
2, sir.
2. Yeah, good. 2 is the least one. Okay, you selected 2. Once you selected 2, now you're going to compare the demand. This is going to be the demand. And they are going to have the supply. Okay, now you compare in this one sometimes you find, as you can see, for example, this one is like we have something which is called 3 by 3. Okay, 3 by 3. Now if you have a 3 by 3, let me increase and put like 110 and 200. Let me put here 300. Okay, 300. It's an example. All right, so now here we have a 3 by 4. Okay, 3 by 4. All right, so as you can see, the value or the least one is found at 3 by 3. 3 the third row to the third column. If in a case, if here was like if here was again 10, so then to be found to the 3, the third row to the fourth column. This is a fourth column, so we can select this one. I think, yeah, we can set this one. So sometimes it will be written like this one. I will write like this, or you may find in a book that the selected cost is a 3, 4. So you will know it's a third row, fourth column. Clear? So now what I was saying is find the least cost value and select it. That's number 1. Number 2, that's what I said. Compare supply and demand. Write down. What I'm going to do for the second point here, you're going to compare. What are going to compare? Supply and demand. What do? You're going to compare supply and the demand. Okay, then allocate the less value, the less value, the less in value. You can put the less in value. Okay, in value. For example, here, same example here, we have, let's take an example here. We have like 100. I have a 200. Here we have a 400. Here we have a 600. Okay, 600. And let's say here we have a 300. Okay, we have a 300. Here we have a 200. Okay, 200, and it's going to be 500. It's going to be 500, and it's going to, let's say I have 800. Clear? Now you check if it is a balance. This one is going to be 1,300, right? For the supply, it's going to be 1,300. And what about this one? 1,300. Then it is a balance. 1,300. Now you look, what is the list? The list is what? The list is 3, right? The list is 3. Now in the list, which is 3, you allocate this one. What do you put? You look what is the less in value among the supply. This is the demand. These are the demand. Okay, and here you have the supply. So between 600 and 800, which is the least, is a 600. 600 will be here. And what I'm going to do is going to be 0, and it's going to be 200, as usual. Now, which is one going to be shade off? We are going to shade this one. This column is going to be, cross off. Now, again, you apply the same. Which is the least again? Which is the least? Which is the least remaining there? Which one is the least? This one is shade off. Okay, this one is shade off. This one is shade off. Okay, which one is the least among the remaining cells here? Which one?
5.
First, which one? 5. Good. 5 is the least one. You select. Now, 5 is allocated or is at position of the third row, second column. It is at the third row, second column. Clear? Now, what do you do here? What are you going to do? You are going to compare the cost of this row. Look, the cost of the source, the supply, and the demand is a 200. It's a tie. When it is a tie like this one, you select any. Okay, you can select. Let me take this one. Let me select 200. Let me select this 200 from which side? From this side. From from this one. Okay, 200. You can select this one or you can select this one because the tie. Okay, this is a tie. When you have a problem, when you have a tie, let me note here. When there is a tie, select randomly. Select randomly. So for our problem, we are going to select randomly. We are going to cross over the row, the third row. Okay, this is going to be 0. Both has to be zeros, right? Zeros, and then we cross this one. Okay. Now we look to the next. What is the next? Which one is least among whatever we have there? Between I think this is the remaining. Okay. Yeah, between the cells which you have here. 11, 110, 11 is going to be the least. Okay, 11 is going to be the least, and this is going to be 200. 0 is this one, so this we call infinite. Okay, we call infinite. Let me give you the feasible one without the tie one, because this will be the second example to digest. Okay, to understand. But both they work the same. Only the concepts are different. Okay, I mean only the calculation. The minor calculation will be there, which are different. Let me give you the feasible one, which does not have a tie. Okay, let me take an example of the source from a source to a destination here. Okay, for this list value, let me take this as example. 1 second. Look here. Here I have a 3, 1, 7, and 4. Here I have a 2. Here I have a 2, 6, 5, 9. Here I have 8, 3, 3, 2. Okay. So these are the cost. These are the destination. Okay. Okay. And apply the same here. Okay. And we have the supply. The supply is the 300, 400. Okay. And it's going to be 500. And the demand is going to be 250. It's going to be 350. Okay. This is going to be 400. It's going to be 200. Okay, 200. Now you check if it is a balance. This is going to be 1,000. This is going to be 1,200. This is going to be 1,200. 1,200. What about this one? 250 plus 50 is a 600, right? 600 plus 600 is equal to 1,200. So it is a balance. Now, what is the next for the list method? We are going to allocate the list value. We are going to allocate the list cost. What is the list cost? 1 is the list cost, right? 1 is the list cost. We are going to allocate it. And it is on the second column, third row, second column. Now you're going to find the difference between the 300 and 200. I mean 350 and 300. The rest is 300. So 300 is going to be allocated here, and this is going to be subtracted, is going to be 0, is going to be 50 rupees. Which one to be crossed? This is the first row is going to be closed. Next, what is the second row? What is the second list? We have again tie. This is here and this one is here. You select any. You select anyone. Okay, let me select this one. You can say this or no problem. You get the final answer. Let me select this and see. So this one, we have this one. And which is the least one? The list is 200, right? 200 is the list between the demand and the cost. This is going to be 0, and this is going to be 300. Clear? Now, next. What is the next? Now, which one to be crossed? This is going to be closed. Okay? This is gone. Now, we remain with these cells. Which is the list? This is the list. Okay? You are going to compare 250 and 400. We put here 250, okay? And this is going to be 0, and this is going to be 150. Clear? Now, this is going to be closed. Now, we remain with 6533. Now, here you can see 3 also is a tie. You can choose any random. Let me choose this. You can choose any randomly, no problem. When there is a tie, you can choose randomly, no problem. Okay, I choose this one. Here we have 50 and 300. Here I put 50, it's going to be 0, it's going to be 250. Clear? 250, it's going to be 250. This is going to be closed off. Now I have a 3 and 5. 3 and 5, which is the list? The list is what? The list is 3. Okay, the list is 3. When the list is 3, which one to allocate? The one to allocate is going to be what? Is going to be 250, and it's going to be 150, and it's going to be 0. Do you see? The 0 and this one, they are same. Clear? The final one which you get is a 0, and the one is a 0. You can see they're same size, same value. So which means that our problem is what? Is Packer. Okay, our problem is Packer. Which one is remaining? This is 0, 0, and 150 as well as 150. So this is going to be allocated as a 150. Clear? Now we are going to multiply 300 into 1 plus what? 150 into 5 plus 50. You can calculate and tell me 50 into 3 plus 250 into 3 plus 200 into 2. 200 into 2. What is the value? Ashish, 200 into 2. Okay. 300 into 1 plus 150 into 5 plus 50 into 3 plus 250 into 3 plus 200 into 2. So you can get the value. Clear? So this is the two methods of transportation which we have seen. From the next class, we shall see another method, which was the third one. What was that one? The third method was this one, the so-called Voges method. Okay, the Voges approximate method. Clear? So this is for the balance. What is the value, Ashish? Which value have you seen for this one? The last one.
2,350, sir.
2,350. Okay, good. So is like a 2,350. Let me 2,350. So the 2,350 is the minimum cost of this problem for transportation from a source to a destination from different sources. These are the source 1, source 2, source 3. These are destination 1, destination 2, destination 3, destination 4. So from all of this one, the minimum cost for transporting your goods or your items, it is 2,350 from any cost, from any source. Okay, so this is it. And thank you for today. Probably by tomorrow, or not tomorrow, the next class we shall look to the next process of this transportation problem.